It entered our story as if drawn from a dream, a solitary voyager, silent and nameless, threading through the familiar geometry of our solar system with the indifference of a ghost. At first, it was nothing more than a shifting point of light against the black tapestry of the stars, indistinguishable from the countless wandering rocks and icy fragments that have forever drifted in our skies. Yet within its subtle motion, there was something alien, something that did not belong. The object slipped into our cosmic neighborhood without warning, moving at a velocity no comet of ours had ever dared, on a trajectory that made no return possible. Unlike the familiar residents of the Sun's gravitational dominion, it was not bound to a repeating orbit, not tethered by the invisible leash of gravity's embrace. Instead, it had arrived from beyond, crossing the vast gulfs of interstellar space, untouched by the Sun until now, destined never to be captured, only to pass through and disappear into silence again. For billions of years, our solar system has been a closed stage, the planets and comets circling in endless repetition. To witness an intruder, a traveler born under another star, was to glimpse the wider theatre of the galaxy itself. It was as if the curtain of the familiar had lifted for an instant, and beyond it lay the incomprehensible immensity of the universe's deeper narrative. What made this visitor unsettling was not simply that it came from afar, but that it came bearing questions it refused to answer. Its brightness flickered strangely, as if its body were shaped in ways that defied natural simplicity. It trailed no cometary veil, no breath of sublimating ice to explain its behavior, and when it departed, it did so with an acceleration no celestial stone should have possessed, as though nudged by some invisible hand. For centuries, humankind has wondered if we are alone in the abyss. This fragment of matter, whether rock, relic, or craft, brushed against that ancient question. Was it the debris of another world, wandering endlessly until chance brought it here? Or could it have been something else? Something made, not born, drifting across the lightless ocean of interstellar space like a bottle with a message inside. It carried no voice, no transmission, no deliberate signal, only its silence. And yet, that silence rang louder than any broadcast could have. It whispered of unknown civilizations, of distant cataclysms, of technologies lost or still hidden in the folds of the galaxy. It stirred both awe and unease. A single stone, perhaps, but one that cracked open the boundaries of our imagination. We named it Oumuamua, a word from the Hawaiian tongue, meaning a scout or a messenger, and with its fleeting passage, the solar system was no longer only ours, it had been visited. The story began on an October night in 2017. Atop the volcanic slopes of Haleakala in Maui, Hawaii, the Pan-STARRS Observatory searched the skies as it always did, mapping faint traces of moving light, cataloguing rocks and comets that brushed the inner solar system. Its purpose was pragmatic: to protect Earth, to spot asteroids that might one day fall into destructive embrace with our planet. Night after night, it scanned, its digital eyes sweeping across the heavens. On that night, it detected something unusual. A faint streak of light so dim it nearly evaded recognition was moving against the background of stars with a pace too quick to ignore. It did not follow the familiar rhythm of local objects. In the hours that followed, astronomers began calculating its orbit. Their numbers unraveled a truth that was both astonishing and unprecedented. This object did not come from within. For centuries, telescopes had charted the dance of planetary neighbors, each comet and asteroid bound by the Sun's ancient gravity. Their orbits curled, elongated, sometimes chaotic, but always belonging to the same gravitational family. This one was different. Its path was hyperbolic, not elliptical. It was not circling the Sun, it was fleeing it. Scientists traced its course backward through time. The lines did not loop back to the Kuiper Belt. nor the Oort cloud, nor any familiar region of our solar system's icy reservoirs. Instead, the path extended out into the wider galaxy, to the unknowable distances beyond. This was no child of our Sunday. It had been born under another star, centuries, perhaps millions of years ago, and had been wandering interstellar space until chance or fate delivered it to us. The object was given a provisional designation, as all new celestial bodies are, C 2017 U1. At first, astronomers assumed it must be a comet. That was the logical category. Yet, unlike any comet before, it bore no trailing veil, no shimmering plume of ice and dust evaporating under the sun's warmth. Its light remained bare, naked, and cold. As more observations flowed in, the data demanded a new classification altogether. It was the first of its kind, a harbinger from outside. For this reason, it was renamed 1I Oumuamua, the one eye, marking it as the first interstellar object ever confirmed, the I standing for interstellar, and Oumuamua, chosen from Hawaiian language to signify a messenger from afar, a scout reaching us from deep space. In those first weeks of discovery, there was both exhilaration and disbelief among the astronomical community. For generations, scientists had speculated that interstellar debris must exist, fragments torn from other star systems drifting between suns. But speculation had been all it was. The odds of detecting one seemed impossibly small. Yet here it was, passing through our solar system with mathematical certainty, its existence undeniable. The discovery carried with it a strange intimacy. Humanity had, for the first time, observed a visitor born beneath another Sunday. Its atoms may have been forged in furnaces alien to ours. Its journey measured not in centuries, but in millions of years. The telescope at Haleakala had opened a window to the greater galaxy, and what stared back was not a star or a planet, but a solitary fragment, a messenger of silence. No one could have predicted what mysteries its passage would unveil. What began as a faint speck of light was about to bend the very fabric of our understanding, challenging the limits of science and igniting whispers of something far more profound. When the announcement of one Oumuamua's existence rippled across the global scientific community, disbelief was the first instinct. An interstellar traveler passing through the solar system, the notion felt almost mythic, closer to the realm of science fiction than sober astronomy. For centuries, the skies had been studied with ever-growing precision, and not once had such a body revealed itself. Yet the mathematics of its orbit was unyielding. There was no other explanation. At first, astronomers tried to fit it into known categories. Surely it must be a comet many bodies enter from the cold reservoirs of the Oort cloud, long-period wanderers that sweep in close to the sun, ignite with a luminous tail, and then return to the darkness. But this object did not return. Its orbital eccentricity was greater than 1, a clear signature of a body not bound to the Sunday. Its speed was far too high, over 87 kilometers per second, far beyond what could be achieved by a mere slingshot around the planets. It had not been accelerated here, it had arrived already moving with the momentum of deep interstellar drift. As the orbital elements became clear, the magnitude of the discovery sank in. For the first time, humanity was witnessing matter that had formed beyond our solar cradle, an emissary from elsewhere. It had no allegiance to the sun, no history tied to our planetary system. Instead, it was part of the great tide of debris that flows invisibly between the stars. Fragments thrown outward when planets collide, when stars form, when systems tear themselves apart. This was cosmic shrapnel, long theorized but never before confirmed. The disbelief was not just scientific, it was existential. Astronomers had grown accustomed to mapping the heavens in familiar terms: planets, asteroids, comets, moons, even black holes and neutron stars, exotic as they were, had become part of the cosmic vocabulary. But this was something altogether new. It was as if a door had opened, and beyond it lay the larger galaxy, reminding us that our sun is not the only architect of celestial wanderers. There was also unease. Why now? Why here? The galaxy is immense beyond comprehension, the distances between stars so great that even light requires millennia to bridge them. The probability of such an object crossing into our solar system at the precise moment when humanity possessed the instruments to detect it seemed vanishingly small. Yet there it was, caught in the act, as if fate had conspired to show us a glimpse of the beyond. Some scientists whispered about statistical inevitability. If billions of fragments roamed between stars, then eventually one must stumble across our path. But others sensed something deeper, an uncanny alignment between cosmic timing and human readiness. Just as our telescopes matured, the galaxy sent us a messenger. Disbelief began to dissolve into a strange mixture of awe and fear. If one object could arrive from the interstellar dark, then surely there must be countless others. What stories did they carry? From what violent birth had they been ejected? How many more passed unnoticed in the eternal night, unseen and unmeasured, drifting past our small system like ghosts at the edge of perception? The discovery had shattered an old assumption that the solar system was isolated, its borders untouched. Now it was revealed to be porous, a crossroads in the galaxy's endless circulation. And as one eye, Oumuamua, continued on its indifferent journey, its very existence forced humanity to confront a humbling truth. We are not observers standing apart from the galaxy. We are participants in it, visited by the same forces and fragments that shape stars and worlds far beyond our own. The disbelief faded, but in its place rose a deeper unease. For while science could accept the mathematics of its orbit, the behavior of this object would soon present puzzles far stranger and far more difficult to explain. As astronomers refined their calculations, the details of the object's journey came into sharper focus. Its trajectory was no simple ellipse, the familiar curve traced by planets, asteroids, and comets, tethered to the sun. Instead, it carved a hyperbolic path, an arc that bent around our star only once, before fleeing forever into the darkness. No celestial body born of our solar system could follow such a course. This was a signature of something utterly foreign. The numbers were precise, yet uncanny. At its closest approach to the Sun, it had skimmed within 0.25 astronomical units closer than Mercury itself. From there, it swung outward, threading through the inner solar system at speeds too great for capture. By the time Earth even noticed, it was already retreating, racing past the orbit of Mars, destined to vanish into interstellar night. The speed alone spoke volumes. More than 87 kilometers per second relative to the Sun, faster than any comet or asteroid we had ever measured. The Sun's gravity had bent its course, but not enough to bind it. The object carried with it the momentum of another star's gravity, the scars of a birth far away. Somewhere, perhaps in the chaos of a young system, it had been flung outward, exiled into the galactic sea. For millions, maybe billions of years, it had wandered in the cold between suns until chance had delivered it across our sightlines. And then there was its angle of arrival. It did not approach along the flat plane of the planets, that ancient sheet of dust where most solar system objects reside. Instead, it dove in steeply from above, like a needle piercing a spinning disk. It did not belong to our celestial architecture. It was a stranger, cutting across the geometry of our system with casual disregard. Astronomers traced its origin backward, extending its hyperbolic arc into the past. No obvious parent star emerged. Its course was ancient, shaped not by a single stellar ejection but by the combined nudges of the galaxy's gravitational tides. The Milky Way itself had been its shepherd, guiding it aimlessly for eons until this chance encounter with our Sunday. Its birthplace remained unknowable, lost in time and distance. Yet what unsettled scientists most was not its origin, but its defiance of expectation. For generations, theoretical astronomers had predicted that interstellar objects must exist, wandering fragments torn from young star systems. But they expected them to appear as comets, icy bodies with tails, shedding matter as they grazed the heat of alien stars. One, Oumuamua, however, betrayed no such behavior. It was as if it had shed its cometary soul long ago, hardened into something else, something unrecognizable. Its path was a reminder of scale. For all the seeming stability of our solar system, we are not an isolated pocket, but part of a vast galactic ecosystem. Gravitational encounters fling matter outward constantly, and those fragments roam, sometimes for eternity, until they intersect another star's dominion. One Oumuamua was proof that the galaxy is porous, that the distances between stars, though immense, are bridged by silent wanderers. But for those who looked deeper, its path carried a deeper philosophical weight. It was not simply passing through, it was departing. We would never touch it, never study it up close, never retrieve a fragment. The mystery was moving away faster than any human probe could dream of chasing. This fleeting glimpse was all we would have. And that fleetingness gave it the air of a riddle whispered in passing. The sun had illuminated it for a brief moment, like a spotlight catching a lone figure on a darkened stage. Then the light would fade, and the figure would vanish, leaving only questions in its wake. The trajectory was mathematics, but to those watching, it felt like something more, a reminder of how vast the universe is and how rare the moments are when its secrets pass close enough to glimpse yet remain forever untouchable. As telescopes followed the fading point of light, another enigma began to surface not in its path, but in the way it gleamed. Normally, a small body in space reveals its dimensions and rotation through the rhythm of reflected sunlight. Astronomers measure the way brightness waxes and wanes, building a model of the shape that causes such variations. For most asteroids, the changes are modest, steady, predictable. But one Oumuamua's flicker told a different story. Its light curve swung wildly, brightening and dimming by a factor of 10. This was unprecedented. To produce such dramatic shifts, the object could not be spherical, nor even moderately elongated. It must have been extraordinary in shape, stretched into an aspect ratio no solar system rock had ever displayed. The models that best fit the data suggested something at least 5 to 10 times longer than it was wide. Perhaps cigar-like, a spindle drifting in over in. Or perhaps flattened, a vast shard or wafer twisting as it tumbled. In either case, it was unlike any asteroid or comet we had seen. The solar system's bodies, shaped by gravity, collisions, and eons of wear, tend toward rough spheres, potato-like forms, or fractured chunks. This object was stranger, almost architectural in its proportions, almost deliberate. It evoked images not of nature's randomness, but of craft, of sails, of fragments cut clean by unknown design. Its rotation added to the strangeness. Instead of a simple spin, the object appeared to tumble chaotically, a motion called non-principal axis rotation. Like a bottle drifting on waves, it rolled unpredictably, perhaps due to some ancient collision. Yet even in its chaos, the brightness shifts remained oddly patterned, as though the surface reflected light in unusual ways. Some models even hinted that it might have been thin, with reflective qualities unlike rock or ice. The telescope data gave no images, only light curves, graphs of brightness over time. From these shadows of evidence, astronomers built conjectures. Was it a shard of rock torn from a shattered world? Was it a splinter of frozen nitrogen or hydrogen shaped by cosmic forces beyond our imagining? Or was it something that nature alone might never sculpt, something artificial, drifting through the void as if abandoned? The speculation, once confined to private musings, soon found voice in published studies. The unusual elongation, the extreme brightness fluctuations, the absence of familiar signatures, all of it invited comparison to sails, to panels, to machines. Few dared to state it outright, but the question lingered. Could such a shape belong to something once built rather than born? The mere act of asking carried weight. Science is cautious, rooted in evidence, reluctant to entertain the extraordinary. Yet this object had broken expectations so thoroughly that even the disciplined language of astronomy could not escape the shadow of wonder. In the wider imagination, the shape became a symbol. To the public, to dreamers, to poets, it seemed the closest humanity had ever come to glimpsing an interstellar craft. Whether shard or ship, it bore with it the mystery of another world's making. Its elongated form was a cipher, written in light and shadow, hinting at stories no telescope could tell. And so, its shape became not merely a question of geometry, but of philosophy. What is natural and what is not? How do we distinguish chaos from design when the evidence is faint, the data fleeting, and the cosmos so endlessly inventive? In its silent tumbling, one eye Oumuamua offered no answers, only the flicker of reflected sunlight, as though it were signaling in a language too alien, too ancient, for us to decipher. The first assumption had been simple. If one eye Oumuamua was interstellar in origin, then surely it was a comet. Comets are the natural vagabonds of the galaxy, icy relics from star-forming regions, cast outward in gravitational slingshots, and when they stray too close to a sun, they always reveal themselves. Heat awakens their frozen cores, releasing gas and dust into a radiant halo, a veil of vapor and ice crystals streaming out as a tail. Such signatures had been seen countless times. They were familiar, expected. But with one eye Oumuamua, there was no tail, no haze, no emission of gases. When it skimmed close to the sun, closer even than Mercury, astronomers waited for the plume to ignite. Instruments were ready to record the faintest trace of water, carbon dioxide, or exotic molecules boiling from its surface. Yet nothing came. The object passed silently, bare, a naked traveler. It defied the cometary script entirely. This absence was not trivial. A comet's outgassing is not just a spectacle, it is a physical necessity. Ice heated by the sun must sublimate. Even the most distant and ancient comets exhibit some trace of it. That one eye Oumuamua did not raise unsettling questions. Was it composed of something different, something unresponsive to solar warmth? Had it shed its volatile ices eons ago, its surface sealed in the deep cold of interstellar drift? Or was it never a comet at all, but something else entirely? Some astronomers leaned toward the idea of an asteroid, a rocky fragment flung outward from another star system. That would explain the absence of outgassing. But here too, the data resisted. The object's brightness, its peculiar fluctuations, its faint reddish hue, these did not align neatly with typical asteroid behavior. It was as though it occupied a liminal space between categories, neither comet nor asteroid, neither fully one nor fully the other. The strangeness deepened further. Later measurements revealed that one eye Oumuamua's path had shifted slightly as it moved away from the Sunday. It was not traveling exactly where gravity alone predicted. A small but undeniable acceleration was present, as if something had given it a gentle push. Normally, with comets, this could be explained by jets of sublimating gas, acting like tiny thrusters. But here, no such jets had been seen. The push was invisible, inexplicable, yet real. The absence of a comet's tail, combined with the unexplained acceleration, placed the object in a twilight zone of classification. It was an anomaly in the truest sense, resisting every framework designed to contain it. And anomalies are unsettling because they do not just challenge data, they challenge understanding itself. The scientific instinct was to search for natural explanations. Perhaps the outgassing was too subtle to detect, masked by the faintness of the object and the speed of its flight. Perhaps it was shedding molecules in ways unlike any comet observed before. Perhaps it was covered in a crust that concealed its activity. Yet each hypothesis felt strained, stitched together not from evidence, but from necessity. And all the while, the silence of its passage lingered. No comet's breath, no comet's veil, just a flickering shard of light, moving with an indifference that seemed almost deliberate. For centuries, humanity had sought to classify the universe, to place each discovery into its proper box. One eye, Oumuamua, refused the boxes. It carried no tail, yet accelerated as if it did. It glimmered like an asteroid, yet rotated as though its body were shaped with purpose. It did not behave like the children of our sun, nor like any visitor imagined. It was as if the galaxy had sent a riddle in stone, wrapped in silence, and the absence of a comet's tail was only the first verse of its mystery. For a brief time, it seemed that the mystery might settle into a natural explanation. After all, even the strangest comet could still obey familiar rules once its details were understood. But then came the observation that transformed unease into astonishment. One eye, Oumuamua, was accelerating. This was no illusion. Careful measurements of its position, tracked against the background stars as it retreated from the sun, revealed a deviation from the path dictated by gravity alone. The difference was small, but unmistakable. Something was giving the object an extra push, nudging it outward faster than predicted. Normally, such accelerations are easy to explain. Comets, heated by solar radiation, release jets of gas and dust. These act like miniature thrusters, altering the comet's trajectory in subtle but measurable ways. This is why comet paths must always account for non-gravitational forces. Yet with one eye, Oumuamua, the paradox was immediate. There was no tail, no visible jets, no detectable outgassing. The familiar explanation had no evidence to support it. What then could be pushing it? Some astronomers suggested invisible outgassing too faint to see. Perhaps hydrogen or other volatile gases were escaping in a way that evaded detection. But models of such behavior required assumptions that strained credibility. The acceleration was too smooth, too continuous. Cometary jets usually create uneven, chaotic forces, yet this push was steady, as though guided by something more uniform. Others wondered about radiation pressure, the subtle but real force of sunlight itself. Photons, though massless, carry momentum, and when they strike an object, they impart a tiny push. For most asteroids and comets, the effect is negligible. But if one eye, Oumuamua, were extraordinarily thin, perhaps no more than a fraction of a millimeter thick, then the pressure of sunlight could indeed account for its motion. This idea carried eerie implications. Nature does not often craft objects so thin, yet durable enough to survive interstellar travel. Technology, however, might. And so, what began as a strange anomaly slipped toward a frontier of speculation that scientists rarely cross. Could the acceleration be artificial? Was this not a stone, but a sail? Not a relic of nature, but a relic of engineering, drifting through the void, pushed ever onward by the faint caress of starlight. The thought was unsettling yet strangely logical. For decades, human scientists had imagined building light sails, vast, delicate sheets designed to harness sunlight for interstellar travel. Projects like Breakthrough Starshot were already exploring the concept, dreaming of sending wafer-thin craft to nearby stars. Could it be that somewhere else in the galaxy, such a technology had already been created and one of its fragments had now passed through our system? Of course, most of the scientific community resisted such an interpretation. Extraordinary claims require extraordinary evidence, and this was still, at its heart, a faint speck of light, its secrets locked in shadows and mathematics. But the data could not be denied. An invisible push had altered its path, and no conventional explanation yet satisfied the enigma. The silence around one eye, Oumuamua, grew heavier. It was as though the universe had presented us with a paradox in motion, an object, neither comet nor asteroid, neither dead stone nor active body, moving with the touch of an unseen hand. The acceleration was more than physics. It was philosophy. It raised questions not just of mechanics, but of possibility. If such a push could exist without outgassing, then perhaps our categories of comets and asteroids were incomplete. And if it could not, if this push was truly something else, then we were left with the whisper of something profound, that the void may not be as empty of intelligence as we once thought. The mystery deepened, and with it, the tension. Was this acceleration the echo of natural processes we had not yet understood, or the footprint of design left behind by hands we had never known? As the data poured in and the enigma grew sharper, a quiet murmur began to ripple beyond the world of scientific journals. For decades, humanity had wondered if the galaxy was silent because it was empty, or because its voices traveled in forms we could not yet recognize. And here, now, was a traveler behaving in ways that strained natural explanation. To some, it was not a comet, not an asteroid, but something altogether stranger, a craft. The very suggestion was heresy to many. Science prides itself on caution, on drawing conclusions only when compelled by overwhelming evidence. And yet, in hushed tones, in conference hallways, and in speculative papers, the idea crept forward. What if this was not a rock, but a relic? What if it was a probe, an artifact of technology, sent long ago from a civilization elsewhere in the galaxy? The shape lent itself to such whispers. Cigar-like, or perhaps wafer-thin, elongated beyond the proportions of any known asteroid. Its acceleration, smooth and silent, with no plume of escaping gas. Its trajectory, hyperbolic, as though it had been aimed not randomly, but purposefully, across the stars. To the speculative imagination, these were not the hallmarks of chaos, but of intention. Such whispers were not born only of fantasy. The idea of interstellar probes had long been part of serious scientific thought. Visionaries like Carl Sagan had speculated about von Neumann machines, self-replicating craft that could wander between stars. Engineers had drawn designs for light sails, for slender sheets pushed by starlight to near-relativistic speeds. If humanity, in its infancy of spaceflight, could imagine such technologies, why should it be impossible for another civilization to have realized them ages ago? To picture one eye, Oumuamua, as a derelict ship was to enter a space both thrilling and terrifying. If it was artificial, then it was likely ancient, drifting for millennia, perhaps longer than our species had existed. Its makers may be gone, their world extinguished, their message forgotten. Or perhaps it was not a message at all, but debris, an artifact cast off, abandoned, left to wander the interstellar tide. Yet the very silence of the object was haunting. No transmissions, no signals, no lights. If it was a craft, it was mute, its systems long dead, or perhaps never meant to speak at all. A relic of another mind, but one that carried no intention toward us. Like a bottle washed upon a shore, its message might not have been written for us, if indeed a message had ever existed. Still, the possibility changed everything. For centuries, the question of extraterrestrial life had lingered in the abstract, an equation with no variables to solve. Now, for the first time, there was an object in our sky that invited the thought, maybe we were not alone. The suspicion alone was enough to ignite imagination, to awaken a sense of awe and dread that no sterile explanation could entirely extinguish. And in that whisper, humanity found itself caught between two narratives. One was comfortingly familiar. Oumuamua was an unusual but natural fragment, a shard of rock or ice behaving in ways we had yet to fully understand. The other was staggering, that it was evidence of intelligence, of agency, of a galaxy that was not silent but filled with relics of those who came before. For the moment, there was no way to choose between them. The visitor gave no answers. It simply drifted outward, indifferent, leaving us with our speculation. But the whispers remained, unsettling and alluring. What if, just once, the question of alien life had brushed against us, not in words, not in signals, but in the silent tumbling of a lone and ancient craft? In the days that followed the discovery, the world of astronomy found itself pulled into an uncomfortable tension. On one hand, the duty of science demanded restraint. Extraordinary claims, especially those that touched the realm of alien technology, required extraordinary evidence. And here, the evidence was faint. A smudge of light across the detectors, a path traced in mathematics, a flicker in brightness curves, nothing more. To leap from such fragments to the idea of a craft risked discrediting the discipline itself. And yet, even among seasoned scientists, doubt lingered. The absence of a comet's tail, the inexplicable acceleration, the improbable shape, these were not small quirks but profound anomalies. To wave them away too quickly felt like a betrayal of the very spirit of inquiry. If science is the pursuit of truth, then should it not be willing to stare into the unknown, even when the unknown resembles the territory of science fiction? The hesitation was palpable. Many astronomers dismissed the alien hypothesis outright, labeling it sensationalist, unnecessary, a distraction from serious analysis. They pointed to the long history of natural explanations for seemingly strange phenomena, from ball lightning to pulsars, once thought to be artificial little green men until nature revealed its complexity. To them, Oumuamua was another puzzle to be solved within the bounds of physics, not a message from the stars. But there were others who allowed themselves to wonder. In conferences, in quiet papers, in late-night conversations, the speculation persisted. If one allows even a sliver of probability for an artificial origin, then the implications are staggering. The first confirmed interstellar object, and it behaves unlike anything we know. Could we afford not to consider the possibility, however remote? What made the hesitation more profound was the weight of history. For decades, the scientific search for extraterrestrial intelligence, SETI, had scanned the skies for signals, only to be met with silence. To many, that silence was evidence that no one was speaking. But Oumuamua reminded them of another possibility. What if the galaxy speaks not in radio waves, but in relics? What if civilizations leave behind artifacts, silent travelers drifting through space, their purposes forgotten, their makers long gone? The tension deepened because the evidence could never be revisited. The object was already fleeing, too distant, too faint. Humanity had no spacecraft ready to chase it, no instruments powerful enough to resolve its form. We were left with shadows of data, enough to unsettle but never enough to confirm. And so, the scientific community stood divided between those who demanded caution and those who whispered that perhaps, just perhaps, this was something more. For the cautious, the path forward was clear. Gather more data, refine models, explore natural explanations until the anomaly dissolved into the known. For the dreamers, however, this was a moment of reckoning. If even 1 in 1,000 chance existed that this was artificial, then ignoring it was a failure of imagination. In this hesitation, the human condition was laid bare. Our minds seek certainty, but the cosmos rarely grants it. Between skepticism and wonder lies a fragile space where possibility shimmers and where truth may be glimpsed only briefly before it slips beyond reach. And so the scientists hesitated, not because they lacked courage, but because the question was too immense to grasp and the evidence too fragile to bear the weight of its implications. Among the many voices weighing in on the enigma, one rose louder than most, not because it was sensational, but because it came from a place of authority. Avi Loeb, then chair of Harvard University's Department of Astronomy, dared to ask the question openly that many only whispered in private. Could one eye Oumuamua be a probe, a fragment of alien technology, an artifact drifting silently through interstellar space? Loeb did not claim certainty. He acknowledged the limits of the evidence, the faintness of the data, the impossibility of proving intent with such meager observations, but he insisted on intellectual honesty. If the object resisted every natural explanation proposed, then it was unscientific to exclude the artificial hypothesis from consideration. To dismiss it outright, he argued, was not caution but bias. Science, after all, is not meant to confirm our expectations, it is meant to test them. In his papers, and later in his widely discussed book, Extraterrestrial, Loeb made the case with careful reasoning. The acceleration was smooth and consistent, as though caused by radiation pressure. The shape, inferred from brightness variations, was unlike anything observed in natural bodies. The lack of outgassing removed the standard cometary explanation. And the thinness required for sunlight to drive its motion on the order of a millimeter was beyond what nature could easily produce, but well within the realm of technology. Together, these clues formed a narrative, not a certainty, but a possibility too extraordinary to ignore. His stance drew both admiration and fierce criticism. To some, Loeb was courageous, daring to bring the question of extraterrestrial technology into serious scientific discourse. To others, he was reckless, undermining the credibility of astronomy by leaning too close to speculation. The debate ignited headlines, stirring both public imagination and professional discomfort. Yet, beneath the controversy lay a deeper issue. Loeb's question was not just about one eye Oumuamua, but about how science treats anomalies. Do we dismiss them until they can be neatly explained, or do we expand our frameworks to include possibilities that challenge the ordinary? Is it more unscientific to speculate about alien technology or to refuse to consider it at all? In raising the possibility of a ship, Loeb tapped into something ancient in humanity, the longing to know we are not alone. For centuries, this longing had been relegated to philosophy, religion, art. Now, through the faint flicker of a distant object, it had found its way into the rigor of astrophysics. The fact that a Harvard astronomer could say aloud what poets and dreamers had long imagined gave the mystery new gravity. Loeb's words did not change the data. They did not alter the fact that one eye Oumuamua was already vanishing, beyond the reach of confirmation. But they changed the conversation. The object was no longer merely an asteroid, nor a comet, nor even just an anomaly. It became a question about evidence, about possibility, about humanity's place in the cosmos. And once that question had been asked by a figure of such stature, it could not be unasked. It lingered in the public imagination, in scientific debate, in the quiet reflections of those who gazed at the stars. Could it be? Could the galaxy have sent us not only rocks and ice, but relics of thought and intention? The answer remained unknowable. Yet, by speaking the possibility aloud, Loeb ensured that one eye Oumuamua would not fade quietly into obscurity. It had become more than a traveler. It had become a symbol, the first object from beyond, and perhaps the first whisper of minds other than our own. The more carefully scientists examined the data, the more the object seemed to stretch the boundaries of natural law. Gravity alone could not account for its path. Radiation pressure required a wafer-thin geometry few believed nature could sculpt, and outgassing, the standard explanation for a comet's subtle pushes, left no visible trace. Each proposed mechanism faltered against the stubborn simplicity of observation. The object had accelerated, and it had done so without the expected signatures. To grasp why this was so disquieting, one must step back into the foundations of celestial mechanics. For centuries, ever since Isaac Newton's Principia, the dance of planets and comets has obeyed strict and beautiful rules. Gravity dictates the arc. Energy defines the velocity. Even perturbations, jets of vapor or pressure from sunlight, fit within calculable margins. The cosmos, however vast, is orderly in its mechanics. But one Oumuamua broke that trust. Its acceleration was about 1 part in 1,000 of the sun's pull at its distance, a tiny but undeniable deviation, small enough to be dismissed as noise if observed once, but consistent across multiple measurements. The laws themselves had not failed, but our understanding of what forces acted upon this object had. The difficulty was not simply that the acceleration was strange, it was that it was smooth. Cometary jets erupt in spurts, causing chaotic twists and lurches. If jets had been at work here, the object's tumbling rotation would have been disturbed, perhaps even destabilized. Yet no such disruptions were measured. The push was constant, elegant, almost engineered. This is why scientists felt unsettled. The anomaly did not look like an accident of nature. It looked like a process steady, efficient, purposeful. And purpose, in the language of physics, is an intruder. Some tried to salvage the cometary model, proposing exotic ices that evaporate invisibly. Hydrogen icebergs, for instance, could sublimate without leaving visible trails. But hydrogen is too fragile to survive millions of years in interstellar space. It would erode long before reaching us. Others suggested nitrogen ice, flung from a Pluto-like world. But this too seemed improbable, demanding more nitrogen debris than the galaxy could reasonably supply. One by one, the natural explanations strained under their own improbabilities. Each could work in theory, but only if one assumed rare and unlikely circumstances. As the models multiplied, the simplicity of the problem remained. The object had moved as if pushed by light itself, and its geometry implied something thin, broad, and reflective. A natural shard stretched like that was not impossible, but neither was it expected. And so, in the quiet of observatories and the pages of journals, the phrase non-gravitational acceleration became a cipher. It stood in for a deeper question. What kind of force, what kind of structure could behave so smoothly, so silently across the void? For some, the answer was that nature is more inventive than we give it credit for. For others, the whisper of engineering could not be ignored. A light sail drifting through the galaxy, catching the breath of stars, it was a vision humanity itself had begun to dream of. Was it coincidence that our first interstellar visitor acted in ways we had already imagined for our own probes? Or was it evidence that minds elsewhere had once walked a similar path of invention? The physics of impossibility had become a physics of unease. The anomaly was real, the explanations uncertain. And in that gap between certainty and speculation, the cosmos seemed to lean closer, as if inviting us to reconsider the limits of what is possible. If the acceleration of one Oumuamua could not be explained by gravity or jets of gas, then what invisible hand was guiding it? One hypothesis grew louder than the rest, not because it was proven, but because it was hauntingly plausible. Radiation pressure, the gentle push of sunlight itself. This idea rested on a simple truth of physics. Photons, though massless, carry momentum. When they strike an object, they transfer a tiny force, like the faintest breath against a sail. Normally, this force is negligible. Rocks and ice are too massive, too thick, to be swayed by such delicate touches. But if an object were thin, extremely thin, its ratio of surface area to mass could become high enough for sunlight to matter. It could move, not by engines, not by jets, but by light alone. Such an object would be unprecedented in nature. Imagine a wafer, no thicker than a millimeter, perhaps less, spread across dozens of meters, durable enough to survive the ravages of interstellar dust, cosmic rays, and the collisions of eons. Could nature produce such a fragile yet resilient geometry? A sliver of planetary crust, shaved impossibly thin, a sheet of frozen hydrogen or nitrogen, hardened into a mirror? Or was this something else, a design, not an accident? Scientists had long dreamed of such sails. The concept of a light sail had been proposed in the 20th century, a method of interstellar propulsion that required no fuel, only the ceaseless flow of photons. Projects like Breakthrough Starshot sought to launch tiny probes, each mounted on a thin reflective sheet, pushed by powerful lasers toward nearby stars. Humanity itself was already sketching the blueprint for technology that, if seen from afar, might look very much like what one Oumuamua appeared to be. The resonance was uncanny. Here was an object from beyond the solar system, behaving as though driven by precisely the mechanism we ourselves were only beginning to consider. A sail adrift, tumbling silently, carrying no crew, no signal, only its strange geometry and the sunlight that bore it onward. If it was natural, it would expand our understanding of what the galaxy creates. If it was artificial, it would expand our understanding of who inhabits the galaxy with us. Either way, the implication was extraordinary. Critics pointed out that thin sheets are unlikely to survive the battering of interstellar space. Dust particles traveling at high relative speeds could tear holes, cosmic radiation could erode their integrity. And yet, humanity's own engineers argued that it might be possible with advanced materials, nanotechnology, or self-healing structures. If we could imagine it, why not another civilization, far older, far more advanced? There was a quiet poetry in the idea. Perhaps this was no probe, no deliberate messenger, but a relic, an abandoned sail, once part of a greater vessel, now drifting alone across the galaxy. Or perhaps it was never meant to survive, merely a fragment flung outward, a shard of alien ambition. Whatever its origin, it seemed to embody intention, even if only in form. The light sail hypothesis did not claim certainty. It was not proof of alien life, but it illuminated a possibility that could not be dismissed. One Oumuamua was more than a rock. It was a mirror, reflecting back not only sunlight, but the dreams and fears of humanity. In its flickering, tumbling silence, we saw both the ingenuity of the cosmos and the haunting possibility that we were not the first to sail the interstellar sea. The moment speculation turned toward technology, the instruments of science turned toward silence. If one Oumuamua was a craft, then surely it might speak. Surely some trace of communication, however faint, might trail behind it an echo of transmissions, a pulse of intent. Humanity had been listening to the cosmos for decades, ears pressed to the void, hoping for the whisper of another intelligence. Now, with a possible relic in our skies, the search became urgent. Radio telescopes across the world were directed at the fleeting visitor. The Green Bank Telescope in West Virginia, the most sensitive single-dish radio observatory on Earth, devoted precious hours to scanning the frequencies. Project Breakthrough Listen. An initiative dedicated to the search for extraterrestrial signals prioritized the object, sweeping a vast range of wavelengths in search of patterns that could betray artificial origin. The hope was that, if it were a probe, it might still carry a transmitter, or at least some unintended leakage of radio energy. But the scans returned silence. No narrowband signals, no bursts of repeating structure, no evidence of communication. One eye, Oumuamua, remained mute, as though either it carried no voice, or its voice was not one we were equipped to hear. The absence of signals was not unexpected. If the object were natural, there would of course be nothing to detect. If it were artificial, it might be derelict, its systems long dead after drifting for millions of years. Or perhaps it had never been meant to transmit, designed instead for some other purpose, sailing, scouting, or merely surviving. Still, the silence was profound. It reminded humanity of the vastness of the unknown, of the humility required when peering into the cosmos. The effort was not wasted, however. The radio searches placed constraints. If it had a transmitter, it was not operating in any frequency we could detect, nor with any power large enough to register at Earth. It was either quiet by design or quiet by decay. The galaxy's messenger, if it was one, carried no words we could decipher. And yet, silence itself can be a kind of message. The quiet passage of one eye, Oumuamua, forced us to consider possibilities beyond the human template of communication. Perhaps alien artifacts do not speak in ways we expect. Perhaps their very presence, their geometry, their trajectories, are their language. A light sail drifting through the stars may not need to transmit. Its existence may be its message. For the broader scientific community, the radio silence was both relief and frustration. Relief because it tilted the scales back toward natural explanations. Frustration because it left the anomaly unresolved. For the dreamers, however, the silence was haunting. It suggested an object that had been set adrift without regard for us, indifferent to our curiosity, an echo of another civilization that had passed too far away in space or time to notice we were here. And so, one eye Oumuamua continued outward, silent under every listening ear. If it was a relic of another intelligence, it carried no invitation, no explanation. If it was a natural shard, it remained unlike any shard we had known. The silence did not end the mystery. It deepened it, turning speculation inward, toward the limits of what we dare to imagine about our place in the galactic dark. If silence defined the object, probability shadowed it. Scientists asked themselves, how likely was this encounter? How often should interstellar debris stray into our neighborhood? And what were the odds that one such body would reveal itself within the narrow window of human observation? The answer was unsettling, for it forced astronomers to reconcile chance with inevitability. The galaxy is ancient and restless. Every star is born amid collisions of matter, and every planetary system sheds fragments into the void. Over billions of years, comets are ejected, asteroids scattered, planets shattered. These remnants do not vanish. They drift endlessly, joining an invisible population of interstellar nomads. For decades, theorists had estimated that countless such bodies must exist, perhaps trillions. But estimates remained abstract, unproven, like whispers of ghosts no one had seen. Then, with the discovery of one eye, Oumuamua, probability was forced into reality. If we could detect one object so soon after building surveys capable of scanning the skies, then the galaxy must be filled with them. The fact that it appeared in 2017, within a few years of Pan-STARRS reaching its stride, implied that these interstellar wanderers were not rare visitors but common drifters, passing through with quiet regularity. But probability cut both ways. If these objects were common, then why had this one been so strange? Why did the very first interstellar object we found resist natural explanation so completely? Shouldn't the laws of large numbers have handed us something ordinary, a dusty comet, a rocky asteroid, rather than a riddle wrapped in anomalies? Was this simply coincidence, or had we glimpsed a statistical outlier that distorted our sense of the norm? Some astronomers leaned on probability to dismiss the alien hypothesis. Given the scale of interstellar debris, it was far more likely that we had encountered an unusual fragment of nature than an artifact of intelligence. Others argued the opposite. If billions of such objects drifted through the galaxy, then surely some fraction could be technological. And if so, was it so implausible that the first we encountered would happen to be one of them? Probability became less about numbers and more about philosophy. It was a question of what humanity was willing to believe. The odds against alien technology were enormous, yet the odds against such a bizarre natural fragment also stretched credulity. We were caught between two improbabilities, forced to choose which seemed less impossible. And beneath this debate lingered a subtler truth. The galaxy is so vast, so ancient, that probability alone may not be enough to guide us. An object can be both unlikely and real. A messenger can appear against all odds, and when it does, the question is not whether it should have come, but what we are willing to learn from its coming. Thus, the problem of probability did not resolve the enigma. Instead, it revealed the limits of calculation. No matter how carefully one weighed the odds, the object remained the same, a silent traveler, defying expectations, its existence both inevitable and impossible. Anomalies are the language of discovery. For centuries, the history of science has unfolded through moments when nature refused to behave as expected. Uranus's orbit deviated from Newton's predictions, and Neptune was found. The perihelion of Mercury drifted, and Einstein's relativity was born. Radio static hissed in Bell Labs, and the cosmic microwave background revealed itself. Every great leap has come not from certainty, but from dissonance. Oumuamua was such a dissonance. It entered the catalogue of human knowledge like a sentence written in an unfamiliar script, its meaning elusive, its grammar untranslatable. Astronomers could describe what they saw, but not why it was so. The object seemed to embody contradictions: a comet without a tail, an asteroid with no familiar shape, a body accelerated without engines, pushed without visible cause. Each anomaly piled upon the last, until the very act of classification began to falter. The language of anomalies unsettles because it forces a choice. Do we stretch existing categories until they bend enough to contain the new, or do we accept that the anomaly demands a new category altogether? With one eye, Oumuamua, scientists leaned first toward the familiar, unseen, outgassing, exotic ices, fragments of planetary crust. But each explanation demanded improbabilities, stacked upon improbabilities. The object remained recalcitrant, resisting translation into the tidy vocabulary of nature. To the philosophical eye, this revealed something deeper about the human condition. We are reluctant to admit ignorance. We prefer awkward explanations over silence, strained models over empty hands. But anomalies speak most clearly when they remain anomalies. They are the universe's way of reminding us that our understanding is provisional, that certainty is a fragile construct. Oumuamua was a word in that hidden dialect. Its silence, its peculiar motion, its impossible shape, all of these were phrases spoken by the cosmos in a tongue we had not yet learned to parse. Some argued that it was a dialect of geology and physics, born of exotic natural processes not yet understood. Others dared to imagine that it was a dialect of design, a language of intention written in the mechanics of light sails and fragile forms. The very act of debating revealed the tension between caution and wonder. Science thrives in the space between the two, but it is rarely comfortable there. To some, labeling it a comet, even an unusual one, was safer, a way to domesticate the anomaly into the familiar. To others, leaving it unresolved, letting it stand as a riddle, was more honest. Anomalies, after all, are not obstacles to science, they are its raw material. They are the cracks in the surface of the known, through which the unknown seeps in. And in those cracks lies the possibility of transformation. Thus, Oumuamua became more than an object. It became a symbol of how the universe speaks, not with certainty, not with clarity, but with riddles carved into the paths of tumbling stones. It reminded us that discovery is not about answering every question, but about learning how to live with questions that may never be answered. And so, the language of anomalies whispered through its passage, leaving us not with conclusions, but with a profound reminder. The universe is not obliged to make sense to us, and sometimes its most eloquent words are those we cannot yet translate. The more astronomers debated, the more they returned to the simplest possibility. That Oumuamua was not a craft, not a sail, not a message, but merely debris, a fragment, a shard cast adrift from a catastrophe so distant and so ancient that only silence remained of its origin. One theory envisioned the collision of planets in another star system, worlds forming in violence, their surfaces shattering under impacts, sending fragments into the void. If an asteroid belt could be born from the remnants of a failed planet, why not a shard flung so hard and so far that it escaped the gravity of its own star forever? Over billions of years, such debris would accumulate, scattered across interstellar space like grains of sand upon a shore. Oumuamua, in this telling, was just one grain that happened to cross our tide. Others imagined tidal disruption, a planet wandering too close to its sun, torn apart by gravity, its crust ripped into thin slivers and hurled outward. Such forces could carve strange geometries, stretching matter into elongated fragments. If so, then Oumuamua's cigar-like or pancake-like shape was not evidence of design, but the scar of cosmic violence. Still others suggested erosion. In the cold emptiness between stars, radiation and impacts with dust might chip away at debris over eons, shaving it into thinner and thinner forms. What remained would not be round or rugged, but smooth and flattened, a wafer sculpted by time itself. If so, then Oumuamua was less a ship than a fossil, its shape a record of processes alien to our solar system but natural on galactic scales. The dark debris theory, as some called it, offered a comforting anchor. It explained without invoking technology. It placed the object within the narrative of chaos and creation that already defines the universe. Stars give birth to planets, planets collide, debris drifts. We are catching only the smallest glimpse of that cycle. And yet, even here, the anomaly resisted full surrender. Could such debris really accelerate without visible jets? Could it remain intact over millions of years, while traveling wafer-thin through dust and radiation? Could coincidence alone deliver such a fragment into our view, just as our instruments became capable of seeing it? For every comfort offered by the debris hypothesis, unease persisted. It explained enough to soothe, but not enough to satisfy. Like a half-answered riddle, it left the listener uneasy, sensing there was still something more. But perhaps that is the true nature of cosmic fragments. They are born in violence, carried by silence, delivered to strangers who can only guess at their story. To call Oumuamua a shard of dark debris was not to solve the mystery, but to accept that some mysteries are fragments themselves, incomplete by nature, whispering only of the whole from which they came. If it was not a shard of rock, perhaps it was something far more delicate, an iceberg of hydrogen. This was another hypothesis that emerged in the months after Oumuamua's discovery proposed to explain the object's mysterious acceleration without visible outgassing. Perhaps, some suggested, the body was composed almost entirely of frozen hydrogen, sublimating invisibly as it passed near the Sun, releasing streams of gas too subtle to be detected by our telescopes. The idea was elegant in its simplicity. Hydrogen is the most abundant element in the universe. In the deep cold of interstellar space, perhaps hydrogen could clump into icy bodies, fragile yet real, waiting to be dislodged and sent wandering between stars. If such an object approached the Sun, even a small degree of warming could cause it to evaporate rapidly, creating thrust without leaving the visible signatures of a normal comet. This could explain the smooth, steady acceleration, jets of hydrogen escaping evenly, invisible to our instruments, pushing the object like an unseen engine. But the theory soon encountered resistance. Hydrogen icebergs, if they exist at all, are profoundly unstable. Interstellar space is not a benign ocean. It is filled with radiation, with cosmic rays, with collisions against dust grains moving at tremendous speeds. Such fragile structures would erode quickly. Could one truly survive for millions of years, crossing the gulfs between stars, without dissolving long before reaching our system? Calculations suggested otherwise. A hydrogen iceberg, the size of one Oumuamua, should have evaporated long before it reached us. To preserve it, the galaxy would need a mechanism constantly replenishing such bodies, flinging them outward in abundance so that one might, by chance, survive the journey. But what kind of astrophysical factory could produce hydrogen shards in such numbers? No clear answer emerged. Yet the idea was not abandoned, because it carried a strange beauty. To imagine hydrogen icebergs adrift in the galaxy was to imagine a hidden ecology of fragile bodies, invisible until they ventured near a star, vanishing as quickly as they appeared. If one Oumuamua was such a body, then it was not a relic of technology, but something perhaps rarer still, a form of matter that nature crafts in the coldest and darkest of places, a visitor born not of design but of elemental simplicity. For those who favored natural explanations, the hydrogen iceberg provided a lifeline. It explained the acceleration without demanding aliens. It framed the anomaly as a window into physics we had not yet observed firsthand. But it also revealed the fragility of our understanding. For every new theory, another question arose. If hydrogen bodies exist, why had we never seen them before? And if they are common, why was the first interstellar object we detected the strangest of all? In the end, the hydrogen theory stood as a reflection of the scientific process itself, creative, bold, willing to stretch the imagination to reconcile data with the laws of physics. Whether correct or not, it was a reminder that the universe is still stranger than our categories, still filled with possibilities not yet measured, still capable of humbling even the most careful equations. Perhaps one Oumuamua was not a sail, nor a shard, nor a comet. Perhaps it was something as fleeting and fragile as an iceberg of hydrogen, passing too quickly to be proven, melting into invisibility even as it accelerated away. A visitor made not of mystery, but of impermanence. If not a hydrogen iceberg, then perhaps something less fragile, yet just as exotic. Another theory emerged in the wake of one Oumuamua's retreat, that it might be a shard of solid nitrogen flung into space from the surface of a distant, icy world. The idea drew inspiration from our own solar system. On Pluto, on Triton, and on other frozen moons, nitrogen ice forms vast plains and gleaming glaciers. Under the right conditions, impacts can chip away at such surfaces, launching fragments outward. If a planetary collision or tidal disruption ejected a large enough piece, it could escape its home system altogether, becoming an interstellar traveler. A shard of nitrogen, polished by eons of drift, could resemble the thin reflective geometry suggested by one Oumuamua's brightness variations. And as it passed near the Sun, sublimation of nitrogen could explain its faint acceleration, all while leaving little visible trace to our telescopes. It was, in many ways, a compelling narrative. The galaxy is full of Pluto-like worlds, small, cold, distant planets covered in volatile ices. If one Oumuamua were a fragment of such a crust, it would not be unique, but part of a larger population. In this view, the object was not extraordinary, but inevitable, one shard among countless others drifting across interstellar space, a relic of planetary surfaces ground down and scattered by violence. Yet again, challenges arose. The amount of nitrogen ice required to populate the galaxy with enough shards for one to cross our path seemed implausibly large. Even if Pluto-like planets were common, the sheer volume of nitrogen debris needed was staggering. Calculations suggested that half of all nitrogen in the galaxy would have to be locked into such fragments to explain the numbers. Could the cosmos truly be so wasteful? Furthermore, nitrogen ice is volatile. Over millions of years, radiation and collisions with dust would erode it. How long could such a shard survive before sublimating into nothingness? The survival time seemed too short for interstellar journeys spanning hundreds of millions of years. The theory explained the acceleration, but stumbled against the demands of endurance. Still, the nitrogen shard hypothesis carried a certain elegance. It anchored the mystery in processes we already knew: impacts, planetary crusts, volatile ices, without invoking alien technology. It made the strange seem natural, the extraordinary seem inevitable. It allowed astronomers to hold on to the belief that, though unfamiliar, this traveler was still a child of nature's chaos, not of another mind. And yet, like every theory before it, the nitrogen shard raised as many questions as it answered. If such fragments exist, how often do they pass us unseen? How many wander between stars, eroding silently in the cold? And if one shard could reach us, then what hidden violence in a distant system had birthed it? Whether hydrogen or nitrogen, shard or sail, natural or artificial, the object remained ambiguous. Each hypothesis illuminated a possibility, but none held the final word. One Oumuamua was a canvas upon which science painted theories, each provisional, each incomplete, each revealing more about our imagination than about the object itself. Perhaps that was the true lesson. In its silence, one Oumuamua forced us to confront the limits of knowledge. Whether it was a shard of alien crust or an artifact of alien craft, it carried with it the same humbling truth, that the galaxy is older, stranger, and more inventive than we can yet prove. As theories multiplied, hydrogen, icebergs, nitrogen shards, tidal fragments, light sails, the debate grew sharper. What had begun as quiet wonder within observatories spilled into the wider scientific community, then into the public sphere. One Oumuamua was no longer merely an object to be studied, it had become a battleground of interpretation. Critics lined up quickly against more exotic explanations. To many astronomers, invoking alien technology was reckless, a violation of the discipline's ethos. Extraordinary claims demanded extraordinary evidence, and in this case, the evidence was faint to the point of vanishing. A few points of light across telescope sensors, a calculated trajectory, a flickering light curve, this was the sum of the data. To leap from such fragments to alien craft, they argued, was not boldness but sensationalism. Science should seek the simplest natural explanation, even if unsatisfying, before turning to speculation. Defenders countered that dismissing possibilities out of hand was equally unscientific. If the natural hypotheses demanded improbable conditions, rare ices, fragile geometries, coincidences stacked upon coincidences, then was it truly more outlandish to consider the artificial? To Avi Loeb and a handful of others, the refusal to entertain the idea revealed not scientific rigor but prejudice, a cultural reluctance to confront what might lie beyond. The clash was not only about the object, but about the philosophy of science itself. Should science protect its credibility by staying within the bounds of the likely, or should it embrace the unknown even at the risk of ridicule? Should anomalies be forced into familiar categories, or should they be allowed to remain as open questions, however unsettling? In journals and conferences, the arguments unfolded with intensity. Some called the alien hypothesis a distraction, an appeal to the extraordinary that undermined the painstaking work of astronomy. Others praised it as a reminder that science is at its best when it refuses to look away from the improbable. The debate became less about Oumuamua itself and more about what kind of science humanity wished to practice: cautious, conservative, and grounded, or daring, imaginative, and willing to risk embarrassment in pursuit of truth. The public, meanwhile, embraced the drama. Headlines declared "Alien Ship" and "Messenger from the Stars," drawing readers into a mystery where hard data could not follow. To many outside the halls of academia, the idea of an interstellar craft was not threatening but exhilarating. It awakened something ancient: the dream of contact, the yearning to know we are not alone. The tension between critics and defenders mirrored a deeper divide between human caution and human wonder. In truth, both sides were driven by the same impulse: a desire for understanding. The critics sought to preserve the integrity of evidence, to keep science free of speculation that could not be tested. The defenders sought to expand the boundaries of the possible, to avoid missing the extraordinary by clinging too tightly to the ordinary. Between them, the debate mirrored the object itself: chaotic, ambiguous, unresolved. And as the arguments continued, Oumuamua slipped farther into the distance, indifferent to our divisions. Its mystery remained unchanged, untouched by criticism or defense. What we debated was not the object itself, but the mirror it held up to us: our fears of error, our hunger for truth, our struggle to balance skepticism with imagination. The greatest frustration of the Oumuamua encounter was its fleetingness. By the time astronomers had realized what it was, the object was already receding. The chance to probe it with spacecraft, to study its structure up close, was gone. Humanity had, for the first time, detected a visitor from another star, and then, in the blink of cosmic time, lost it. This loss sparked an unsettling realization. If one such object had entered our solar system, how many others had passed unnoticed? Before the advent of wide-field sky surveys like Pan-STARRS, our instruments were blind to faint, fast-moving visitors. The cosmos may have sent many before, each slipping silently through the inner solar system, each vanishing without record. Oumuamua might not have been unique at all. It may have only been the first we caught in our net. The telescope had not failed. It had done exactly what it was designed to do: detect threats to Earth, near-Earth asteroids large enough to matter. But its design was not optimized for spotting the faint signatures of small, hyperbolic intruders. That we found Oumuamua at all was an accident of vigilance, a stroke of timing, a reminder of how much still evades our gaze. This awareness haunted astronomers. If objects like Oumuamua are common, then our ignorance of them is profound. They may carry secrets of other planetary systems, histories written in their composition, even relics of alien technology. Yet they pass us by, unseen, each one a missed opportunity. We have been living in a cosmic crossroads, without knowing it. The realization also sparked urgency. If we missed countless visitors in the past, then perhaps countless more will come. The task was no longer to interpret a single object, but to prepare for the next. Could we build instruments sensitive enough to catch them earlier? Could we launch probes swiftly enough to intercept them before they vanish? Could we transform fleeting glimpses into encounters that yield answers? The knowledge that the cosmos had been whispering to us all along, and that we had not heard, carried a quiet sting. The universe had not withheld its messengers. We had simply not been listening with ears sharp enough to hear. One Eye, Oumuamua, was not only a puzzle in itself, it was a mirror held up to our limitations. It revealed that the solar system is not closed, not isolated, but porous, its skies crossed by countless wanderers. And it revealed, too, that we are still blind to most of them. The one we saw was strange, perhaps the strangest we could have hoped for. But the ones we missed, what stories did they carry? What mysteries slipped past, unseen, into the night? The lesson of One Eye, Oumuamua, was clear. If one interstellar visitor had arrived so quickly after our telescopes gained the sensitivity to see it, then others must surely follow. The challenge was not whether they existed, but whether we would be ready to notice them. And so, astronomers turned to the sky with new resolve. One project rose at the forefront of this quest: Atlas, the asteroid terrestrial impact last alert system. Built in Hawaii, like Pan's stars before it, Atlas was designed to scan the heavens for objects on paths that might intersect Earth. Its purpose was defensive, to provide days or weeks of warning before a small asteroid could strike. But in the process, it also became a sentinel for the unexpected, its watchful eyes sweeping the skies each night, building a map of motion against the tapestry of stars. Atlas was not alone. Across the world, surveys multiplied. Pan, stars itself, continued its vigil. The Catalina Sky Survey in Arizona tracked near-Earth objects. And soon the Vera C. Rubin Observatory in Chile promised to revolutionize the field with its wide-field, high-resolution gaze. Together, these systems were transforming the night sky from a canvas of mystery into a dataset of motion where faint intruders might finally be noticed before they slipped away. The importance of this work could not be overstated. For centuries, humanity had gazed at the stars as passive observers, unable to track more than the brightest wanderers. Now, we were entering an age of vigilance, a time when every small flicker of light might be captured, catalogued, and studied. If interstellar objects crossed our skies frequently, then soon we would catch them not by accident, but by design. And with that, readiness came a quiet anticipation. Perhaps the next visitor would be ordinary, a comet with a tail, a fragment that fit neatly into known categories. But perhaps it would not. Perhaps, like One Eye Oumuamua, it would defy expectations, raising new questions, perhaps even more than questions. For if these messengers came often, then the dream of sending spacecraft to meet one was no longer impossible. The next time, we might not simply watch it flee, we might chase it, touch it, even bring back a piece. Atlas was, in this sense, more than a telescope system. It was a promise that the skies would no longer slip by unnoticed, that the galaxy's debris, its stones, its shards, its relics, would be caught in our gaze. It was humanity's way of saying, we are watching now and we are ready. And soon that vigilance would be rewarded. Another visitor was already on its way, destined to prove that One Eye Oumuamua was not alone. In 2019, just 2 years after the fleeting passage of One Eye Oumuamua, the universe delivered on its promise. Another traveler appeared, and this time, astronomers recognized it almost at once. It was discovered by an amateur astronomer, Gennady Borisov, scanning the skies from Crimea with a homemade telescope. At first, it was thought to be an ordinary comet, one of many catalogued each year. But as its trajectory was measured, the same signature appeared: a hyperbolic orbit. It was not bound to the Sunday. It was another visitor from the interstellar sea. Designated 2-1 Borisov, it soon became the second confirmed interstellar object to pass through our solar system. Unlike 1I Oumuamua, however, this one carried fewer riddles. Its appearance was more familiar, comet-like, trailing gases and dust, as the sun's warmth awakened its frozen body. Where the first had been an enigma, the second was a reassurance. Interstellar visitors were real, and they were not all as strange as our first encounter. Later, yet another object, provisionally named 3I Atlas, was flagged by the very survey designed to catch such wanderers. Though smaller and less prominent in the public imagination than its predecessors, it cemented the pattern. The galaxy was not silent. It was populated with travelers, fragments of other suns' histories, drifting through our skies. The arrival of these new visitors shifted the tone of the debate. 1I Oumuamua could no longer be dismissed as a freak, a statistical outlier so improbable it could not be real. With Borisov and Atlas, interstellar objects were no longer theory but evidence repeatable, observable, inevitable. The universe was confirming what many had suspected. The galaxy is full of messengers, and Earth is merely one stop on their endless journey. But the contrast between them also deepened the mystery. For while Borisov behaved like a comet, outgassing and trailing in predictable fashion, 1I Oumuamua remained unique. Its silence, its acceleration, its peculiar shape, unlike anything seen before or since. In the company of these later visitors, it became even stranger, like a lone voice speaking in a different dialect. To scientists, this was a gift. With more examples, comparisons could be drawn. Perhaps 1I Oumuamua was an outlier of natural processes, or perhaps it represented a different class of object altogether. To philosophers and dreamers, however, the juxtaposition was haunting. Why should the first interstellar object humanity ever saw be the one that refused to fit? Was this chance? Or was it a sign? As if the cosmos had chosen to whisper its most enigmatic word before any other. With the discovery of Borisov and Atlas, a new era had begun. No longer would interstellar visitors be dismissed as improbable. They were part of the galactic rhythm, and humanity had only just begun to tune its instruments to hear them. The gates had opened, and through them, more travelers would come. The arrival of 2I Borisov and later 3I Atlas offered astronomers something they had craved since the confusion of 2017, a chance to compare. For the first time, 1I Oumuamua's strangeness could be placed side by side with interstellar kin, and the comparison was stark. Borisov behaved almost exactly as expected. Its tail was bright and unmistakable, a plume of gases venting into the void as the sun's heat gnawed at its frozen heart. Spectral analysis revealed cyanide, carbon monoxide, and other familiar cometary compounds, the same volatile ices that fuel comets in our own solar system. Its composition suggested it was built in much the same way as comets we know, only under another star. In every respect but its orbit, it felt ordinary. Atlas, though less famous, reinforced the same pattern. Smaller, fainter, more difficult to study, it nevertheless bore the fingerprints of cometary behavior. Where 1I Oumuamua had been silent, strange, and accelerating without explanation, Borisov and Atlas were noisy, familiar, and predictable. This contrast only deepened the riddle of the first visitor. If interstellar objects could be so thoroughly ordinary, then why had the first been so extraordinary? Why had 1I Oumuamua been the one to defy classification, to provoke whispers of sails and alien craft? Was it simply an outlier, a rare fragment unlike most? Or did its difference point to a hidden diversity of interstellar wanderers with categories we had yet to even imagine? To scientists, the comparison brought a mixture of relief and frustration. Relief, because Borisov and Atlas confirmed that interstellar debris exists in abundance and that most of it obeys familiar rules. Frustration, because the uniqueness of one Oumuamua could not be explained away as mismeasurement or statistical anomaly. Its strangeness had to be real. Philosophically, the juxtaposition was uncanny. Humanity's very first glimpse beyond the boundary of the Sun's family was not a comet like Borisov, nor a faint shard like Atlas, but an object that seemed almost crafted to provoke question, as if the cosmos had staged its introduction with a riddle before showing us the ordinary truths. Some clung to this thought with unease. Perhaps our first messenger was unique because it was not mere debris. Perhaps it was the relic of intention, arriving first not by accident, but by design, or by the peculiar logic of probability that ensures the most unusual always stands out. And so, the contrast between one eye and its successors became part of the story itself. Together, they told us that interstellar objects are real, common, and natural. But apart, one eye whispered something else, that the galaxy may harbor surprises still stranger than we dare assume, that our first interstellar encounter was extraordinary not only in timing, but in nature. The ordinary reinforced the extraordinary. The familiar made the strange stranger still, and in that contrast, the enigma of Oumuamua refused to fade, its uniqueness more pronounced than ever. As more interstellar visitors revealed themselves, scientists began to step back and ask a broader question. What do these wandering messengers tell us about the galaxy itself? If fragments from other systems cross into our solar neighborhood with measurable frequency, then the space between stars is not empty at all. It is threaded with highways of debris, cosmic routes shaped by gravity, chaos, and time. The motions of such bodies are not random. Each one is born in a moment of violence, a collision between planets, the disruption of comets, the scattering of asteroids during the birth throes of a star system. Once flung outward, they fall under the sway of the galaxy's vast gravitational tides. Over millions of years, their paths stretch into arcs and curves, forming invisible currents that sweep them from one star to another. Our solar system, far from being isolated, lies within these silent streams, a crossroads where interstellar traffic passes unnoticed. To imagine these highways is to glimpse the hidden architecture of the Milky Way. For every Borisov or Atlas we detect, countless others must have slipped by, tiny stones tumbling along unseen roads. Their trajectories are not chance, but the outcome of galactic dynamics, the collective pull of stars, planets, and dark matter weaving a web through which debris endlessly drifts. These highways carry more than stone and ice. They carry history. Each fragment is a record of the system that birthed it, its composition reflecting the chemistry of its home star, its structure whispering of collisions and erosions under alien suns. To intercept such an object is to intercept a page torn from another world story. Borisov's gases, rich in carbon monoxide, spoke of a birthplace colder than our own solar nursery. Perhaps one Oumuamua, with its strangeness, was likewise a clue to processes we had never before witnessed. The existence of these highways raises an even deeper question. If natural debris flows along them, then why not technology? A civilization older and wiser than ours might see the galaxy not as a barrier but as a network, a lattice of pathways to be traveled, mapped, and seeded. For Neumann probes, light sails, or other artifacts could ride these streams as naturally as comets do. If such relics exist, they would not need to aim for us deliberately. The highways themselves would bring them to our doorstep in time. Thus, every interstellar visitor is more than a curiosity. Each one is evidence that the galaxy is alive with motion, that stars are not sealed kingdoms but participants in an exchange of matter. Every system pollutes the void with its fragments, and every system, in turn, is visited by the fragments of others. In this way, the Milky Way is less a collection of isolated stars and more a vast ocean of migration, where debris is the current and planets are the shores. To follow these highways is to glimpse our place in that ocean. Earth is not an island untouched. It is a coast washed by waves from distant storms, a port where travelers sometimes land without warning. And if we have only just begun to notice them, then perhaps the greatest revelation is this: the universe has been speaking all along, in the language of fragments, sending us messages carried not by light or radio, but by the endless drift of stones across the stars. Each visitor, whether comet-like or enigmatic, carries with it the memory of another Sunday. These fragments are not merely rocks, they are messengers, imprinted with the chemistry and history of distant worlds. To study them is to glimpse the diversity of the galaxy, written not in starlight, but in matter itself. 2. Borisov, with its abundant carbon monoxide, hinted at a home colder than any place in our own solar system. It told us of planetary nurseries where frozen gases persist in quantities our sun's warmth would never allow. One-eye Oumuamua, silent and shape-shifting, seemed to speak of processes, stranger still, perhaps shards of shattered planets, perhaps structures thinned to the limit of survival. Each object was a fragment of a larger narrative, a story of worlds forming, colliding, and dissolving under alien skies. To hold such visitors in our telescopes is to hold pieces of other histories. They are physical evidence that we are not isolated, that matter itself migrates across the galaxy. A shard from a planet's crust could wander for eons and then pass through our system, carrying in its atoms the fingerprints of a star we may never see. In this sense, each interstellar object is a cosmic message in a bottle, not written in words, but in chemistry, shape, and motion. The galaxy, then, is not silent. It speaks constantly through these travelers, though the language is subtle, requiring instruments, patience, and imagination to decipher. Where light from distant stars tells us of atmospheres and temperatures, these messengers tell us of collisions and births, of geologies and catastrophes. They are samples delivered without our asking, pages from other worlds' archives dropped into our skies. Yet there is also a symbolic weight in their arrival. To a species that has long wondered if it is alone, the presence of interstellar objects is a reminder that we are part of something larger. Even if no civilization wrote these messages, the galaxy itself writes them. Every fragment that crosses our path declares, "You are not alone in your processes, not unique in your dramas. Other stars too have worlds. Other worlds too are broken and remade." Some take the thought further. If natural messengers can travel between stars, then perhaps so too can artifacts of intelligence. If fragments of stone and ice carry stories, might fragments of design carry intentions? The line between nature and technology grows blurred when both may ride the same highways of the galaxy. In the quiet of observatories, as astronomers chart faint points of light against infinity, the philosophical truth becomes clear. The galaxy is not a place of isolation, it is a place of exchange. Not of voices, perhaps, but of messengers, stones, ices, relics that drift from system to system, binding the stars into a shared story. And so, each visitor is more than an object. It is a reminder that we are part of the Milky Way's grand narrative, and that even in silence, the galaxy speaks. If shards of stone and ice can wander between stars, then why not ships? This question haunted the imagination of scientists and dreamers alike. For centuries, humanity has envisioned ways to escape its cradle not only with rockets, but with concepts designed to bridge interstellar distances. Light sails, nuclear pulse drives, self-replicating probes, all ideas born in human minds, fragile sketches of how one might cross the abyss. If we can imagine them, could others have built them long before us? The thought of von Neumann probes' self-replicating machines emerges here with chilling clarity. First proposed in the 20th century, these hypothetical explorers would multiply as they traveled, harvesting raw materials from asteroids and comets, building copies of themselves, spreading exponentially across the galaxy. Within a few million years, a blink in cosmic time, such probes could, in principle, explore every star system in the Milky Way. If even one civilization had arisen millions of years before us, the galaxy could already be filled with these silent scouts. One eye Oumuamua invited this speculation because its behavior resembled the principles of such craft. A thin geometry, perhaps a sail, a smooth, inexplicable acceleration as though harnessing starlight, a trajectory that carried it not back into orbit, but onward, endlessly outward. These were not proofs, but they rhymed with the very technologies humans themselves dream of building. The unsettling possibility was that we were not imagining futures, but glimpsing echoes of them, futures that others had already lived. Even if not von Neumann probes, simpler relics might drift between stars, defunct sails, abandoned scouts, fragments of alien engineering left behind like fossils, their purposes long extinguished. In a galaxy billions of years old, civilizations may rise and fall countless times. Their artifacts, durable and indifferent, could outlive them, wandering forever through the void, arriving at systems like ours not by intent but by chance. For some, this idea was thrilling. It suggested we might someday intercept not just comets but relics machines, derelicts, vessels, silent evidence that intelligence is not unique. For others, it was sobering. If such relics exist and we have not seen them, then perhaps they are subtle, hidden, disguised as stones. Perhaps we have already passed them by, mistaking them for natural debris. In this light, one eye Oumuamua's silence was not absence, but ambiguity. Was it merely a shard of frozen nitrogen? Or was it a relic of intention, a sail adrift, a probe long dead but still carried onward by light? The line between natural and artificial blurred, and in that blur lay possibility. If ships can drift between stars, then perhaps the galaxy is already seeded with them. Perhaps the interstellar highways we imagine for debris are already highways for machines. Perhaps what we saw was not the first, but only the first we recognized. And if so, then the enigma of one eye Oumuamua was not only a question of science, it was a question of recognition. The universe may already be speaking through relics, waiting for us to learn how to listen. The puzzle of one eye Oumuamua drew astronomers into a role they rarely claim for themselves, detectives. With no probe to chase the object, no sample to analyze, and no second chance to observe, the only evidence left was a faint trail of numbers, light curves, trajectories, spectroscopic hints. From these fragments, science tried to reconstruct a story, as if piecing together a crime long after the scene had gone cold. The tools were equations and models, simulations run across supercomputers, each one attempting to reproduce the object's observed behavior. What combination of mass, shape, and composition could yield the acceleration? What kind of surface could flicker so dramatically in brightness? Each hypothesis was like a suspect in an investigation, some more likely than others, but none entirely free of contradictions. Cometary models strained. Exotic ice theories stretched credibility. Light sail proposals wandered into speculation. Each left fingerprints but not confessions. And so, the mystery persisted, unsolved, each clue pointing in different directions. Yet this detective work was not in vain. In studying what one Oumuamua was not, scientists refined their understanding of what interstellar objects could be. They learned that our telescopes had been blind to an entire population of wanderers. They discovered that new surveys, more sensitive and wide-ranging, were needed. They began to map the probabilities of collisions, ejections, and galactic tides with sharper precision. Even in the absence of resolution, the anomaly sharpened the tools of inquiry. It also revealed something deeper about science itself. The role of the scientist, like that of the detective, is not always to solve the case, but to preserve the integrity of the questions. Some mysteries are never closed, not because they are unsolvable, but because they demand patience beyond a single lifetime. One Oumuamua may remain forever ambiguous, but in that ambiguity lies its value. It keeps us searching. The detective metaphor extended to the broader quest for extraterrestrial intelligence. SETI itself is a kind of forensic science, scanning the skies for anomalies, radio signals, unusual patterns of light that might betray intelligence. One Oumuamua was a reminder that evidence may arrive in unexpected forms, not as a broadcast but as an object, not as a deliberate message but as a silent relic. The task of science is to remain open to such forms, to recognize that the extraordinary may wear the mask of the ordinary. The investigation of one Oumuamua, then, was less about closing the file than about refining the methods. Every telescope pointed at the heavens became part of the search. Every new survey became a potential witness. The mystery lingered, but the tools grew sharper, the questions more precise. In the end, the detective work did not reveal a culprit. It revealed a process, a way of listening to the universe through its anomalies, a way of learning not only from answers, but from the refusal of answers to appear. Science is not always about resolution. Sometimes it is about holding the evidence carefully, acknowledging its limits, and waiting for the next clue to arrive. And in this waiting, the stars themselves became the courtroom, the gallery, the archive of mysteries still to come. As the debates cooled and new theories accumulated, one truth remained. There were no final answers. The data set was too thin, the object too distant, the opportunity too brief. One Oumuamua had slipped into the dark, leaving behind only puzzles and probabilities. And in its wake, the scientific community faced a difficult lesson in humility. The modern age of astronomy has grown accustomed to precision. Telescopes map galaxies in exquisite detail. Satellites measure cosmic microwave ripples to the thousandth decimal, and equations predict the birth and death of stars with remarkable confidence. Against this backdrop, the mystery of one Oumuamua felt like a regression, a reminder that the universe is under no obligation to yield clarity, even to our finest instruments. The humility lay not in admitting ignorance, but in recognizing its value. For to sit with the unresolved is not weakness, it is the essence of science. Each unanswered question becomes a doorway to discovery, an opening into realms we cannot yet imagine. The fact that one Oumuamua remained inscrutable did not diminish its importance, it magnified it. Theories will continue to multiply. Some will insist on exotic ices, others on nitrogen shards, still others on sails and probes. Each carries pieces of plausibility, each stretches the imagination in useful ways. But perhaps the most significant legacy of this interstellar traveler is not the possibility of aliens or the cataloguing of strange physics. Perhaps it is the reminder that certainty is a luxury the cosmos rarely grants. In this humility, there is beauty. The unresolved keeps wonder alive. The unanswered fuels vigilance. The fact that we do not know compels us to look again, to build better surveys, to prepare for the next visitor. The silence of one eye, Oumuamua, does not close the question. It preserves it, like a seed awaiting germination in future minds. For humanity, this is a test of patience. Will we demand conclusions where none can be given? Or will we learn to dwell in the uncertainty, to let mystery shape our questions rather than force it into premature answers? The humility of uncertainty is not resignation, it is a posture of openness, a willingness to accept that the universe still surpasses us. And in that humility lies a deeper reflection. Perhaps what matters most is not what one-eye Oumuamua was, but how it changes us, how it teaches us to listen more carefully, to prepare more earnestly, to wonder more deeply. The object may be gone, but the humility it leaves behind may prove to be the greater gift. For in the long dialogue between humanity and the cosmos, the most important words are not always answers. Sometimes, the most important word is silence. In the end, the story of one-eye Oumuamua is not only scientific but philosophical. It asks questions that press beyond data and instruments, questions that reach into the marrow of human existence. What does it mean for us to live in a universe where such mysteries pass silently by? What does it mean for us to confront an object that defies every neat category we have built? For millennia, humanity has sought certainty. We carved order into the heavens with myths, then with mathematics, then with the precise tools of science. Each step gave us the illusion that the cosmos could be tamed, reduced to predictable equations. Yet here, in the 21st century, an object appeared that reminded us of our limits. It said, in its silent passing, "You do not know everything. You may never know everything." This is not a defeat, but an invitation. To embrace mystery is to embrace the vastness of existence. If one-eye Oumuamua was only a shard of rock or ice, then it still testifies to the violence and creativity of the galaxy, to the unending story of worlds being born and destroyed. If it was something more, if it was a relic of intelligence, then it forces us to confront our solitude, to admit that the stars may hold not only light but memory. In either case, the philosophical lesson is the same. The cosmos is not a machine built for our comprehension. It is a wilderness, sublime and terrifying, where meaning must be sought rather than given. We are wanderers ourselves, brief travelers through time, staring into an abyss that will always surpass us. And yet, in that abyss, we find reflection. The object's strangeness mirrors our own longing to understand, our refusal to accept the boundaries of knowledge. It reminds us that questions are not failures but pathways, that mystery is not emptiness but fullness, charged with potential. To encounter something inexplicable is to be humbled, but also to be enlarged. It stretches the horizon of the possible. It teaches us that to exist in this universe is to exist in dialogue with the unknown. Each anomaly is not an interruption, but a continuation of that dialogue, another verse in the cosmic poem that will never be finished. Thus, the philosophy of the unknown is not despair but wonder. It is the recognition that uncertainty itself is sacred, that in our brief lives we are granted the privilege of glimpsing mysteries far older and greater than ourselves. One-eye Oumuamua was one such glimpse, a reminder that the universe does not belong to us, but that we belong to it, and that belonging is measured not in certainty, but in awe. It has gone now, swallowed by the vastness, retreating into the dark where no human eye will ever follow. One-eye Oumuamua will not return, not in our lifetimes, not in the lifetime of our species. It came swiftly, silently, and left us only with questions, and yet its absence does not diminish its presence. The whisper of its passage lingers, like a dream that clings to waking. Even now, Astronomers recalibrate their instruments, surveyors widen their nets, and theoreticians polish their models. But the object itself is gone, indifferent to our need for answers. It is as if the cosmos allowed us a fleeting glimpse of a secret, only to close the curtain again. The story it carried is lost, but the echo of that story remains, etched into our imagination. Perhaps it was nothing more than a shard of frozen matter, wandering for eons, carried across the galactic tide. Perhaps it was a fragment of nitrogen ice, a hydrogen iceberg, or some exotic geometry carved by violence and chance. If so, then its strangeness is testimony to nature's inventiveness, to the infinite variety of worlds scattered across the Milky Way. And yet, perhaps it was more. Perhaps it was a relic of technology, a sail once harnessed to the breath of stars, or the husk of a probe long since dead, drifting across epochs with no memory of its makers. If so, then its silence was not absence, but message, that intelligence has stirred elsewhere, and that the galaxy holds relics of their journeys, waiting to be noticed. We will never know. That is the truth. The mystery will not resolve into certainty. And maybe that is the point. For in leaving us unanswered, the visitor has given us something more enduring than facts. It has given us wonder. Wonder is the fuel of science, the seed of philosophy, the breath of human curiosity. To be confronted with the inexplicable is to be reminded of our place, not as masters of the universe, but as participants in its vast, unfolding story. One Oumuamua reminded us that the universe is alive with questions, and that the act of asking is itself a form of belonging. Now it drifts among the stars again, nameless in the silence, one shard among countless wanderers. But in our memory it will remain singular, the first messenger, the first scout, the first voice from beyond. Its whisper has not faded. It lingers in the hum of telescopes, in the debates of scientists, in the imaginations of dreamers. It is gone, but it has left us changed. And so, the question endures, unresolved yet luminous, artifact or stone, ship or shard, messenger or accident. The universe will not tell us. It never does. It only shows us mysteries, and then moves on. The night sky is unchanged. The stars still burn in their slow rhythms. The planets still wander along their ancient paths. And yet, for us, something is different. We know now that the solar system is not sealed, that the darkness between stars is not empty, that wanderers can and do arrive bearing their riddles. We lie beneath those same skies, gazing upward, and somewhere out there, one Oumuamua continues its endless journey. It does not know we noticed. It does not care. Yet it brushed us nonetheless. And in doing so, it reminded us of what it means to notice, to pause, to wonder. There is comfort in this thought, that mystery is not absence but presence, that questions are not failures but gifts, that the unknown, vast and unsettling as it is, can be a source of beauty. For what greater privilege is there than to live in a universe where mysteries still remain, waiting for eyes to find them? And so the visitor recedes. Our questions remain. They will be asked again when the next interstellar traveler arrives, and again when others follow. Perhaps one day answers will come. Perhaps one day we will launch our own messengers, our own sails, and meet them along the highways of the galaxy. Until then, we wait and we wonder. The stars above us are silent, but their silence is not empty. It is a silence filled with possibility, with stories not yet told, with voices not yet heard. Sleep well, traveler, sleep well, dreamer. The mystery lingers, but so too does the wonder. The cosmos has spoken, and it has left us with the sweetest of gifts, a whisper we cannot forget. Sweet dreams.